turn off my video now. Okay, and microphone.
All right. So thank you everyone for joining. My name is Brandon Leach. I am the manager of data engineering at Berkeley Research Group. I am also a data infrastructure architect. I've worked in some of the top hedge funds globally, including Citadel, AQR, Chicago Trading Company, etc. So I do data engineering at severe scale, basically. When I was at Citadel, I was responsible for the architecture, along with my co-architect TG, for the design of systems that processed 20 to 40% of all the daily liquidity in U.S. markets. If that's not scale, I don't know what is. Anyways, I'm also a former Microsoft Data Platform MVP. My LinkedIn profile, you can find it at the bottom of the screen. It's just /SQL Server Nerd. And I've been doing this for about 15 plus years. I recently, a few years back, started learning Snowflake as well. Because at Citadel, we weren't just using one platform, we were using multiple platforms. And I found I rather enjoyed it. It's different from SQL Server in some ways. It's more flexible in some ways, and it's more limited in others. So today we're going to talk about that. Now, just to confirm, everyone can see my slides, okay? Is that correct, Valerie?
Yes, sir.
Yes.
Awesome. So regardless of whether you are a SQL Server DBA or a data engineer, or you own a platform, this will help you get an understanding of how SQL Server and Snowflake compare and how certain concepts translate. I specifically wanted to avoid sounding like a marketing speech, because if you've ever seen an introduction to Snowflake webinar, they talk about a bunch of unrelated features and they don't really give you anything you can actually use. Like, you ask about backups, they say they don't have backups. Well, that's not true. They're just different. Very different. So the whole point of this presentation is to help you translate your instincts as a SQL Server professional and understand and see how Snowflake deals with those same concerns, just in a different way. So for example, in SQL Server, when we provision an instance, whether it's physical or virtual, we're concerned with CPU, memory, and I/O, all three tie together. If you tweak one, it has an impact on the others. For example, if you add memory, you might see that your I/O improves. Technically you'll be doing less of it. So you may reduce a bottleneck in your storage by adding memory. Snowflake, those things are completely separate. CPU and memory are still together. They go hand in hand, but storage is completely separate. Its own compute underneath the hood. One does not impact the other. We're going to get into these in a lot more detail shortly. This session is jam-packed with things. So be prepared to kind of have a bit of brain melt, and that's okay. Just post questions in the chat. Valerie will stop me occasionally, and we'll go through some of those. I'd rather you get answers to your questions rather than just kind of leaving you hanging if you have them. The more you understand, the better you will see the pros and cons of Snowflake as a platform. And we will admit Anil. All right.
I'm
So,
taking care of it. Don't worry.
all right, good. So I already mentioned the compute and storage separation, right? We need to understand that some things in SQL Server that we kind of thought of as this is just how it is no longer apply. To that end, there was a similar shift specifically to indexes in SQL Server when SSDs were introduced. Because the whole point of defragmenting indexes back in the day was to have, our rows contiguous. Well, SSDs destroyed that. We got increased performance, but we could no longer guarantee that things were going to line up nicely. So that was a shift where statistics maintenance was still valuable, but index rebuilds really weren't, except for space savings within our tables. Indexes don't exist in Snowflake. I'm just going to say that straight out. What they have instead is something called micropartitions, and we'll discuss those in a section or two down the line. So, if your instinct is just, where are the indexes? We don't have them. Now, another major shift is from infrastructure to governance. What this means is, well, we're not really managing servers anymore. All of that, for the most part, is abstracted away from us. And our role shifts more into governance. So if anyone had any multi-tenant instances, maybe you got some vendor databases for one team, then you've got another team that has a different workload. We tried as SQL Server DBAs to split those out into separate instances when we could, but that's expensive. So we would implement things like the resource governor feature in SQL Server to create guaranteed resources for certain groups. Snowflake has a much better story around that. It's called warehouses, and that's actually the next section. But with that, we also have to understand that because this is a cloud-based platform, it's easy to burn a lot of money. So we actually end up in cost governance as DBAs. I know that sounds strange, but chargeback models actually become kind of a thing for us. And you'll understand this more in depth as we go through. So in order to control performance and cost, that's where the warehouses come in. So let's actually talk about the separation of compute and storage. So in SQL Server, everything is coupled together, right? Your CPU depends on memory and I/O. Your memory depends on CPU and I/O, and your I/O depends on CPU and memory. So, if we push one lever, we then end up making, for good or ill, a change to the overall system through the other levers. So it's a balancing act, right? I gave you that example earlier of the memory pressure increasing I/O because data's flushing out of the cache in SQL Server, and so it has to go back to disk more. Well, that's not going to happen in Snowflake. There's no competing of resources, as I mentioned. You can create separate warehouses for OLTP, reporting, and ETL, or any number of groups. Heck, you could do a warehouse per employee if you want. Additionally, with SQL Server, we have failure domain. It's a single point of failure. If the instance crashes or we need to patch it, that instance goes down. So we build these super costly HADR setups with multiple systems to increase availability and minimize impact of DR events. Snowflake does that in all of this in 3 layers. The cloud services layer is where you log in. It handles query optimization, security. Infrastructure is maintained behind the scenes. You don't see it. And then the warehouses are effectively our resource governor. There are compute resource. They're a collection of CPU and memory, and they may be 1 or more nodes. Again, the section after this is where we're going to go deep dive on those. And then the third layer is the storage layer. It's all columnar micropartitions, meaning it's built like column store. In fact, there's no row store in Snowflake. Everything is effectively column store. There's behind the scenes, they're storing it depending upon your platform on S3 if you're AWS, or Azure Blob if you are Azure. And that storage is shared by all warehouses, meaning any warehouse can access any data at any time as long as the user has the correct permissions. And within a region, there's redundancy built in. So, if an availability zone goes down, you will still be up. If you want actual DR, well, we'll talk about that. That's going to be an additional charge, but it is automatic with automatic failover if you configure it. So we actually just kind of went over this slide. So let's talk about what shifts here. So when a user comes to you and says the query is slow, right? We go on to the instance, we start looking at wait stats. In Snowflake, we don't do any of that. We just kind of ask ourselves, what warehouse is this under? Then we can look at the warehouse and we can say, oh, we need to increase that temporarily for an hour from, say, a small to a medium. And that will resolve the issue, and then we can pull it back down. This is possible because the storage is separate, it's redundant. There isn't really a bottleneck on the storage. So, multiple things can read from it at the same time. It's a whole different world. If you think you need more RAM, you scale up a warehouse. If you think you need more CPU, you scale up the warehouse. And that comes in 2 forms. We'll get there. Now, additionally, because warehouses are separate compute resources and storage is also completely separate, then your analytics team isn't impacting, daily operations or a research team. Right, so say you've got reporting and analytics. If they each have their own warehouse, they're not going to butt heads. They're going to be able to access the same data independently. They do not affect one another. And the third thing is, when we set up these systems in Azure, a SQL Server VM, or on-prem, there's a price we pay for that system to be running. Right? Well, with Snowflake, when When a warehouse is actively running, meaning a query is being run against it, it is incurring cost. But when it is idle, it suspends itself. And that means that you're not incurring any cost. The warehouse isn't doing anything. It's not consuming any resources. So you're not paying for that. So depending on your use case, this could actually be cheaper for you, or it could be more expensive. You have to actually run the numbers here. Click off. The other thing is, if compute fails, the storage persists. If you've got enterprise, then also known as business critical, then you will automatically fail over and be running in a few minutes, or a few seconds, I should say, out of another region. Any questions so far before I move on?
Nothing so far. You must be doing awesome.
All right, so let's talk about warehouses in depth. You can think of the warehouse as an instance if you want. I don't really think of it that way. I think of Snowflake accounts as an instance with multiple compute components. So all a warehouse handles is compute, nothing else. Warehouses, as I've said, they can query things, the same data simultaneously, and they auto suspend and auto resume. You're only going to pay for it when it runs. They come in a few sizes. So the smallest is extra small. I absolutely recommend that when you can. I'll also recommend a small and a medium. Anything higher than that, I really caution you, because you'll start to use credits like crazy. I mean, by the time you get to 6XL, you're talking 512 credits an hour. Retail price for credit is about $3.33. Nobody actually pays that. There's always a contract that reduces that cost, but generally we want to try to use the smallest warehouse size possible for our load. So what I would recommend you do is you start with an extra small, see how far you can get with it, and size up appropriately based on that particular set of queries. Additionally, creating more warehouses, right, for different things, different queries, can help you to scale out. There's another option too that's, well, we'll get to it in a moment. So, and that's called nodes. So before we talk about nodes, let's talk about the warehouse life cycle. So the first thing we do is create a warehouse. As soon as we do that, it is set to suspended. As soon as we use that warehouse to run a query, it's brought into a running state. And then when that query is done, if there's no other queries to run, it will suspend. Now, the thing to note is, if we can keep these things running, if we have enough stuff to keep these things running, it makes sense to do so. If I just write select one and the warehouse starts up and then that's the only query I've ran, that probably took it a microsecond and it charged me for a whole minute. Right? So that's not ideal. It's not terrible for it to suspend. Ideally, you do want them to suspend, but if you can kind of line things up for it to do, that is enormously beneficial. Why did it switch slides on me? All right, so by default, every warehouse will auto suspend every 60 seconds, and auto resume will be set to true. Right? So try to keep your warehouses small. You want your max cluster count. Sorry, I was saying node. I should have said cluster. Typically, you're going to start off with one cluster. You can increase this up. And sometimes it's cheaper to increase the cluster count. In fact, often it's cheaper to increase the cluster count, meaning the amount of parallelism that can happen behind the scenes here, rather than increasing the warehouse size itself. So play with the cluster count on your warehouses. Now, multiple warehouses provide for workload isolation, right? We kind of talked about this a little bit. We're just showing you here kind of what that actually looks like. So in this case, ETL, BI, data science, and ad hoc are all able to go against the same storage at the same time without interfering with each other. And they're isolated to their own warehouses. So they're not bumping heads at all. That whole blocking thing, it goes away. Now, I mentioned we kind of get into cost governance, and we've talked a little bit about credits and kind of how they're used. You saw in the graphic that an extra small is 1 credit, and then it went all the way down up to 512 credits per hour. Well, this is the calculation. So they take the warehouse size by the amount of time, times it by the amount of time running, times the credit price, and that's how much you just spent. So this is very easy for us to tabulate. In fact, we can tabulate it down to a query. We can say this query, just this one query, here's how much it costs us to run for every run. It's really cool. Let's talk about multi-cluster here. So when we scale up, that's when we're moving from one warehouse size to the next. So an extra small to a medium, etc. But we can also, as I mentioned briefly, scale out the number of clusters within a warehouse. So if you've got a lot of users that are going to be in there using that warehouse, scaling out rather than scaling up is going to be your cheaper option. Because now instead of just having one cluster of nodes, you have 2 clusters, each with 4 nodes. Right, and then if you move to Excel, those clusters are going to be 16 nodes. So there's 2 ways to kind of scale with Snowflake.
So these scale out that you're mentioning, right? So whatever you selected as your base node, that is what will be available in like 4 nodes or 8 nodes or 12 nodes or 16, right?
Correct.
Okay, thank you.
Yeah, so in XS you get 1 node. That's going to be one at a time running there, 1 query at a time. So if you and I, Paresh, we both run a query, one of us is going to have to wait. If I, however, take that XS and I set max cluster to 2, well, we're both going to have our own cluster. It's going to be able to run 2 things at once. It's going to cost a bit more, but it's not going to cost as much as making the jump from an XS to a medium, or from an XS to a small.
And the reassimilation of the data that has been processed on the scaled out clusters is similar to MapReduce in Hadoop?
So I'm not really familiar with how MapReduce and Hadoop works.
Basically, it sends out a whole bunch of packages. Say you have 1 million packages, it will send it out to 10 nodes. It has addresses of all those 10 nodes. It sends out those 10 nodes process, and then they send back the results with the address. So they are collected then in one master node, so to speak. So I think this is what Snowflake did too. So, but you can continue. Sorry.
No worries. That's a great point to make. Yeah, it sounds similar. The main point about this is, each node can handle a query, right? So, or it could multiple nodes could be assigned to one query. So we're expanding our ability to process things simultaneously. So when do you want to use a bigger warehouse? Well, if you see that spills are happening to disk, that'll equate to spills into TempDB from SQL Server. Or you've got a really complex query that's slow, right? Then it might make sense to jump up the warehouse size, or more memory / parallelism because of concurrent users. All right. So I am going to show you this this demo here. I need to just go to Teams for a second and switch over my window, because I think this one is important to see. So I'm in here. I'm in Snowflake. When you first come in here, one of the first places you're going to go to is Workspaces. And it's probably going to make me log in again. Oh, nope. Great. So what we're going to do is go up to the top here. If we want to create a demo warehouse. Oh, sorry, I hit F5. I'm still very used to SQL Server. I should be hitting this play button right up here. All right, so I've set myself to the sysadmin role. And right here, we've got a create or replace warehouse statement. Now, one of the things I do really love about Snowflake is because you can use create or replace on just about anything, whether it's a compute resource, a procedure, a database, a table definition, a user account, or role, you name it. Create or replace exists. So in this case, we're going to create a warehouse called Demo Warehouse 2. I already have a demo warehouse set up, but I want to walk you through creating this one. So if I run this, it tells me that it succeeded. We can see that in the other one. So that's the original. So let me do %. And right here is the one we just created. Now I'll explain why I didn't just want to recreate the one from earlier later if we get to the cost governance demo. So we're going to say use that warehouse. Use is also something that we can use a role, we can use a database, we can use just about anything. So I'm going to set myself to use that specific warehouse. And I'm going to run this query here. We're going to count from the Snowflake sample data. And by the way, this exact same database with the exact same data, if you set up a trial account with Snowflake, you will have this preloaded. And we get a simple count of a lot of zeros, about 15 million, I think. So We'll notice when I run this again that it should be it should be suspended again. It should have suspended it pretty quick because of the settings here. Yeah, we can see it started up and then it went right back and suspended itself. So now what we're going to do is we're actually going to run a heavy multi-table join. We're going to let that execute.
While that is executing, can I ask a super dumb question?
It's already done executing, but yes.
Oh, damn. Okay. So does GitHub Copilot have teeth into this, or you have to query or test your queries or write queries using offline Copilot or cloud or whatever?
You can absolutely ask Copilot and GitHub queries about Snowflake. I do it all the time.
Okay.
There is, so technically Snowflake has its own AI agent built right in. That's what you see here. It says, hi Brandon, how can I help? And this is Cortex. It says Coco up here, but that's just the agent on top of Cortex. I can ask this any question I want. I want a super heavy query to show just how, well, I can't even see what I'm typing. Just how much data Snowflake can crunch. If I hit enter, it's going to give me, it's going to think about it for a while, just like Copilot. It's effectively Copilot under the hood. I'm just putting that out there.
That makes sense. Yeah, thanks.
Now, if it's going to produce me a query, I'm going to take a glance at it and see if I want to use $400 worth of credits towards it. But we'll let that run. There's something I want to show you in here a little later, but for now we've run that. So now we need to let's see, use warehouse. It's a demo. We just ran that. So we are going to run this query, but we're going to change it to 2. And now we're going to run up here. The F5 equivalent, yeah, query produced no results. So let's do this. I've run it. Yep, still no results. All right, so yeah, there's nothing to diagnose. But the point is you can catch the skill spill programmatically. However, if I run this again, I want to show you something in here. All right, so once this query finishes, we'll see just how many rows it crunched. So up here, there's this little kind of clock icon.
Somebody wants the font size to be increased. Praveen is saying, yeah.
I can do that.
I think that's fair. Yeah,
That's
Praveen, is
about
that
as
good
good as
for
I'm
you,
going to
sir?
get. So what I did was I came in, I clicked this here, and then I pulled out the query hash. I clicked on it, and it brought me over to here. Now this has some general interesting details about the query that was run. But what's even more interesting is this. Right? This is the execution plan. They call it a query profile. Now in this case, this query was just fairly light. I probably didn't click on the actual one. So let me go back here and identify it. Okay, no, I did. But there are, if I go back, you know what, let's go for the, let's go for this guy and just see if there's a query profile that's more interesting. Oh, it's because, sorry, I was trying to see if I could get more. All right, well, we'll figure out what that's working. For now, we'll just go back to the slides. I gotta bring some of this down, but I can increase the font size again later. All right, so let's go back to the slides. So that, sorry. Because I really need to pick up the pace here. There we are. All right. So we will save any remaining demos to the end. So in this case, the warehouse is the unit of work. We can scale up or scale out. We can separate our users into different warehouses. The warehouse size controls the amount of parallelism. And instead of read replicas for concurrency, we can have multi-cluster warehouses, and they can be automatically spawned. So let's start talking about databases, schemas, and objects, because things, they look similar, but things are a little bit differently. So in SQL Server, our databases are essentially MDF and LDF files. Usually there's only a small number of them. Each database has its own recovery model, transaction log, and backup strategy. Schemas are organizational namespaces within a database, right? So they're sometimes used for security, sometimes not. In Snowflake, they very much are a security boundary. And so moving data between them requires a few extra steps. Cross-DB queries are obviously possible, but underneath the hood, it has a bit more of an impact than it does in Snowflake. And also, dropping a table is painful. Never mind dropping a database. In Snowflake, if someone drops a table, you use the undrop command and it's magically back. Don't tell your users that. Now, a lot of vocabulary is similar. Some of it's new, though. At the top of the hierarchy in Snowflake is the organization. Org admins can create accounts. People can be assigned as account admin, giving them permissions to manage everything below. So the databases, the schemas, the objects. Some people have a set of databases within a single account that are production and dev. Others separate those out into completely separate accounts. You might also have a DR account for your prod, right? So an account admin is a sysadmin on steroids, and an org admin is even higher level access. Now, underneath account admin is your databases. Underneath those are schema and objects. So just like SQL Server there. However, there are no physical files for your database. It's metadata. The data is stored at the object level in micro partitions, right? So the schema is pretty much the same concept. You can use three-part naming, database, schema, table. In fact, you will find that's even more common in Snowflake than it is in SQL Server. And everything is column store. Nothing is row store for your tables. Views are the same. Store procedures are actually expanded on in Snowflake. For example, you can use more than just SQL to define your store procedure. I wrote one the other day in Python. Another coworker of mine actually wrote a Snowflake stored procedure in JavaScript. Right? And then because databases are really, the storage is at the table level, or sorry, object level, file groups are not a thing that you worry about. Snowflake handles all of this under the hood. Now, another thing that Snowflake has is zero copy cloning. So if you're familiar with DBCC clone DB, then you know that that will copy the schema. It's, and that's about it. Like if I go and want to create a copy of the database, I've got to actually do a full restore. I can take a database snapshot, but it's not really creating me a clone. In Snowflake, we can create a clone of the entire database and everything in it, all the data. And it takes about a millisecond. They're using a process similar to database snapshots, except once you've done it, it's fully editable. You can write to it. It's officially its own thing, and as writes happen, it will copy those micro partitions over in the background. Right? So it's copy on write. So for example, if you want to take production data and put it in dev, you can absolutely do that. All right. Any questions before I move on?
I think he's happy with the font. So yeah. How does CI/CD tie in here is the question by Praveen Ahuja.
So that depends how you set it up. I mean, you can use, if you're using GitHub or GitLab or whatever, all your CI/CD stuff can integrate directly with Snowflake, right? Just as you can integrate it with SQL Server, but it's on you to set that up. Does that answer the question?
Manish is also asking something feverishly. He'll be there.
Okay.
He's saying we have SQL Express editions where we can just install and play around. Is there something similar in Snowflake? I think Snowflake gives you a $400 credit.
Yeah.
For whatever duration. I don't remember that. Is that 30 days or just $400?
30 days. Yeah. There is there is no express edition, quote unquote. You can create an account and just use an extra small warehouse if you want. Again, you're not paying for compute costs if you're not using it, right? But the trial they give is $400 in credits, and it's good for 30 days. But no, there is no direct correlation between SQL Express and Snowflake. It would be nice if there was. I wouldn't have to create a new email address every time I go to show Snowflake. All right, indexes and data organization. So there are clustered indexes in Snowflake. You should rarely use them. So you'll define a clustered index based on the scale of the table, right? If you're talking millions upon millions of rows, like tens or hundreds of millions, a clustered index is going to help you. But indexes aren't really a thing in Snowflake in general. Stats maintenance, it's done behind the scenes. You do not need to worry about it. So none of these things apply anymore, really. What Snowflake does is the micropartitions. So they divide your tables into 50 to 500 megabyte compressed chunks. This happens when the data is ingested. You don't do anything. And then it creates column level min-max metadata. So this is kind of your automatically built statistics. And then query pruning. This is what you will have to pay attention to occasionally. No, we do not need to rebuild our indexes or update stats. But once in a while, we're going to want to prune our micropartitions. Usually that happens on its own in the background, but very large tables, you're going to have to get in there and kind of tweak things a little bit. So clustering keys, that's what I was talking about earlier. These do exist. They are not indexes. They're essentially primary keys. That's all they are. So separated out from the clustered index. They really help with the very large tables or tables where there's a lot of filtering by the same column, right? Or if you're loading data out of order. Because remember, we ingest into these micropartitions, order can kind of matter there. It won't help with your small tables or even your medium-sized tables, or if your data is high cardinality, random access, or constantly updating tables. So most tables don't need a clustering key. Measure it and make that determination down the road. So our tuning instincts change. We do partition pruning. We prune the micropartitions via where clause. Right? This is automatic. The same is true of statistics. It's automatic. There's no drift, no worrying about bad query plans. If there is a bad query plan, it's because the query is bad, not because of statistics. Select star, just like SQL Server, it's actually important for performance at scale. Don't use select star, list out the columns you need. All right. Only select the needed columns and you won't need covered indexes. And that query profile I showed you earlier, that is your execution plan. Skip that because we've got about 10 minutes and several more sections to go through. Sorry, I got a little lost in the weeds on the earlier demo. All right. Let's talk about security because this is different too. You're used to granting access to at a database level, and someone can read everything in that database. It doesn't work like that in Snowflake, right? You know about logins, users, roles, and schemas as containers. Snowflake works differently. Snowflake's role-based access control, the roles actually inherit upwards. No users are assigned role, or sorry, no users should be assigned direct access on anything. All permission should be granted to roles, and then users granted those roles. So like everyone gets public, don't put anything in public. Then down here we have kind of the next layer up the chain. You have transformer, analyst, loader. These are roles that are custom roles. And then you have on top of that sysadmin and security admin off to the side, followed by account admin and then global admin above. Right? So typically what I do is I leave my default role as public. And then when I come in to do something, I switch to a custom role with the access I need. I try to avoid sysadmin, and I definitely avoid account admin. This means I am following the concept of least privilege. Additionally, Snowflake has more permission types to grant, right? You're all familiar with insert, update, delete, select. Truncate is its own thing here. References is its own grant here. Right, so you need references to grant to create a foreign key on a table.
So is truncate like a DDL or a DML in Snowflake?
So that would be DML.
Oh, okay.
I mean, it's still kind of in that gray area, but give me 1 sec. I need to blow my nose. And then there's execute, alter, and control. All of these things you're kind of aware of already because they have a SQL Server or equivalent, except for view definition, which is just SQL Server only. But there's also Snowflake only privileges. Usage allows you to actually go in and use something. So like select out of it, insert, touch it, basically is what it allows you to do. Now, you need to grant usage to the user on the database, the schema, and the table. If you miss any one of those chains, any one of those, and you try to query that table, it will fail. So let's say I granted on the table, but not the schema and the database. I will be denied access. I have to grant it on all three, the whole way down. So that's something to take into account. It's different from SQL Server in that sense. Monitor allows someone to view query history, credit usage, performance metrics. So that would be something you grant to like Datadog. Sorry, that was a loud bang. Operate allows you to start, stop, suspend, and resume a warehouse. So if you want someone to have control over a warehouse, you would grant them operate on that. That's going to be pretty much all your users because they're going to want to actually start them up. And modify allows you to change property on things, specifically warehouses, database, or schema. Additionally, there's a couple more. So the thing is, like, I can go and I can grant access on all the tables, but if I add a new table in Snowflake, everyone has to be granted access to that new object again, even though it's been granted on the schema. So to solve this problem, there's a grant called grant future, right? You can see that syntax here. Grant select on future tables and schema blah to role analyst. This is a wonderful thing. You set this up, and now any new table that gets created in that or object in that schema, they'll be able to select from it. Additionally, with Snowflake, you're going to be responsible for working with your networking teams to define authentication controls, as well as you're defining access policies, network policies, encryption, etc. You will get into the weeds with this working with your sysadmin, or sorry, your network team. But it's not something a DBA typically has to worry too much about with SQL Server. You do here. All right, let's talk about backups and HADR because this is important. So it is true there is no real backups in Snowflake, not like you think of them, anyways.
Is that the time machine or?
That is, yes. It's called time travel.
Time travel, okay.
So this is configurable, but in standard edition, you have 90 days of time travel you can do. In dev edition, it's 24 hours. So you can go back to any point in time within that 3-month window and restore to it instantly. And you control it, so you set how long it can go back. Additionally, there's a failsafe. So, once things age out of time travel, they're actually kept in what's called failsafe. That gives you an extra week, but you have to call Snowflake support to recover from it. And I assure you, that gets you the same response time as if you called Microsoft. So it's a slow, painful process, but they can make it happen for you. Their answer to availability groups is replication. It's not SQL Server style replication. Yes, you can replicate over individual tables or entire databases.
So Brandon, it is exactly 8 o'clock. If you have time, then you can continue, but people should know.
Okay. I do have time, and I'm sorry we're running over.
Okay.
So database replication in Snowflake is two-phase commit based. So if your data is guaranteed to be on the other side once that replication job runs. So you configure the replication job. You say, I want it to go over every 10, 15 minutes. And that's your RPO and RTO. If the system goes down, you could lose up to 10 minutes because you've scheduled the job to run every 10 minutes. So this brings up the question. What happens if you have a 7-year retention policy? So you have a couple options. You have an option here. Most people do this in a 2-layered approach. So they'll create a 0-copy clone of the database that moves the data into a separate database, and then they will copy data out of that into an external staging area like S3 or Azure Blob. This helps you to meet that. You can stick it there for however long. But if you're like me and you've got 20 petabytes of data in Snowflake, that gets pricey.
Mhm. And you don't have to actually do any compression or anything, right? Even when you move, because this column store ensures that this is all compressed in general, or
Well,
yes and no?
here's the thing. You're thinking about it slightly wrong. So,
Okay.
when you create a zero copy clone, yes, it's column store, it's compressed. That is true. The moment you export data,
Then it sucks. Okay.
right? It's not in the same format anymore.
So it's just like a rows and columns, or maybe just chunk of data, basically.
Yeah, think of it like a gigantic set of CSVs,
Oh, okay. Yeah.
right?
Got it.
You would need to compress that yourself.
Okay. Got it. Cool.
So you can also put it into whatever format you want.
Got it.
So whereas with high availability in SQL Server, we did AGs and FCIs. We do multi-cluster, multi availability zone architectures already built in with Snowflake. Whereas with SQL Server, we have to kind of do rolling patches in an HADR solution, or we have to accept downtime for standalone systems. These are all transparent in Snowflake. We might do log shipping or availability groups for DR. This is just built in and easy to use in Snowflake. We can get submitted RPO, but your RTO is going to depend on your replication config. With SQL Server, we've got infra, so we have to create our runbooks, our failover drills, the infrastructure. With Snowflake, we don't have any of that. Failover is just a command for the most part. And as long as using the connection URL, which is like a listener, like an availability group listener, users don't even see a break. So, workload management and governance. This is the last section, finally. So in SQL Server, we split workloads using the resource governor feature, which was great, but oh, could it be better? We would use that to manage who got what memory, who got what CPU. We'd also set the max server memory to protect kind of the OS because we didn't want SQL Server to starve the OS. We'd configure other things like max degree of parallelism, and then we'd use DMVs and Profiler to troubleshoot things. Well, none of that is a thing in Snowflake. So we create a warehouse for each team, and that isolates them from everyone else. We can create resource monitors, which are badly named in my opinion. Effectively, it allows us to set budgets. So like we could put a budget cap on a warehouse and say after this much should spend, shut it off or notify someone. We tag things with queries, which allow us to attribute things like cost or anything else our heart desires. And because of this tagging and the isolation to individual warehouses, cost governance becomes trivial. So let's talk about resource monitors first. So, this can send an email alert when credits hit the threshold. Then you can have it automatically suspend No new queries can start. It does a graceful shutdown. In-flight work gets completed. But the warehouse can't be used until an administrator kind of goes in there and allows it to be used again. And then there's suspend immediate. This is just the kill switch. This is like walking up to your server and reaching in and just plucking out the CPU while the system's running, or plucking out all the CPUs, or pulling the power cord, however you prefer to destroy your systems. Yeah, the warehouse stops. All queries are canceled. It's a hard reboot. So I won't get into how to tag right now. We just don't have that much time. But tags are very powerful. We can tag based on certain process, team, job, cost center, feel good message of the day, whatever you want. And that makes it easy. For example, I could tag a set of queries that are part of a refresh process, right? And then I could query that tag later on and see, okay, how much did the refresh process cost us this month? Right? And now I can put a dollar amount. Well, I can put a credit amount, which I can translate to a dollar amount easily, to say, this is the cost of this thing.
Great. Okay.
Right.
We don't have anything similar in SQL.
No, there isn't.
Yeah, this is pretty cool.
Yeah, it's a huge game changer because now we're directly involved in cost attribution. There's no question of, well, they use this system so much, but these guys also use the system. I don't know how much to charge each in a chargeback. Now it's, here's exactly what you spent and here's exactly what you spent. Figure it out and pay me. You can be your favorite debt collector is what I'm saying. So we will skip this for now. The road ahead, 5 big ideas delivered. Compute and storage are completely separated. That changes a lot of things, makes things that weren't possible in SQL Server absolutely possible. The mental models in this deck are a starting point. They're not the ceiling. There are things that are familiar constructs, but don't really have SQL Server equivalents. They just work in too different of a way. It's like comparing an apple tree to, bamboo. Oh, sorry. Operational concerns. Well, we're less concerned with the infrastructure and more concerned with governance. And in terms of performance and scale and cost, the virtual warehouses are your single biggest lever. So here is a link to the where you can sign up for the trial account. That's what I used for the demos. So you can take my demo scripts and you can just run them right there. Also, the official Snowflake documentation. There's Snowflake University and the community forums. So I am going to stop sharing there, and I do want to run a couple more queries if that's okay. But feel free to ask questions while I'm doing this.
People, if you like to come online and then talk about it, that's fine too, okay?
All right, let's Let's
I
look.
have a question for the Snowflake's 30 days trial. If you have $400 credit, but if you didn't use them out by end of the 30 day, will be gone, or you
Yes.
still put.
Yeah, they'll be completely gone.
So
Oh.
Chin is one of our board of directors members. So
Okay, gotcha. Thank you.
By the way, I pulled up a simple cost query here. What this does is it looks at the warehouses that I've tagged with the engineering tag. And it's showing me that we've used about just under 1 credit, about 3/4 of a credit. So if I times that by my credit price, then it will tell me exact amount in USD that
like 4.6 cents, really?
yeah.
Oh wow. Okay.
Well, hang on. All right. So cloud
So there's
service
more.
credits,
Yeah.
that's your storage.
Okay.
The compute credits are what cost more. So let's just say if you're paying $1 per credit, you're paying about 75 cents for your compute and storage.
Okay. For this demo,
right? For this demo.
Okay.
The data in here is delayed about 45 minutes to 3 hours for it to update properly. So I actually ran this query last night so that it would be in here.
So that you can demo. Okay.
Yeah.
Okay. Cool.
I didn't think anyone wanted to stay on the Zoom for 3 hours.
Nah, not a great idea. Cool.
So, but this is how easy it is. I know engineering is costing me
Because
about.
you put the tag there, right?
Yep.
Okay.
In fact, you can see where I did that up here at the top. Where is it? So create the warehouse. Use the schema. Yeah. Yep. And then this is the once I've created the tag, we send it over here and we define it as engineering.
Cool.
So yeah, nice and simple. So if that executes, right now here it all is. I'm listing out my cost centers and the warehouses associated with them. Run this. This may be the one I ran before. Yeah, this is the one I ran before. Here's similar. But it had no data. Okay, that's interesting. But yeah.
Okay, that sounds good. And anybody else have questions? I think all thank you, a lot of them. So this is good, Brandon.
All right. Let me close this for 1 second. I want to reopen this because I want to see if they can show you a decent query plan. Here we go. This is the query profile. This is a query. This is an execution plan. Very similar look.
Mm-hmm.
In this case, in the case of our query, we're barely doing any work.
Yeah.
But it gives you a nice idea.
What is that secure view? Why is that 85%?
Because this is effectively almost the scan. And it's doing the most work in the table. Similar to when you're looking at an execution plan and it gives you the percentage of the plan that was spent on a specific node. That's what that is.
Okay.
So, yeah.
Nice.
Yeah, It's pretty awesome. So secure view is accessing that secure data.
Got it. Okay, so you want to call it a wrap? You have something else, or?
I think so.
Cool.
Thank you for the extra 20 minutes. Sorry, I blew 20 minutes on that earlier warehouse demo.
Let me stop the recording and then